This class, we go down to single digits.
Yeah.
Isn't that
Wait,
awesome?
gotta grab this.
Homework, go.
Yes. I suck at
I don't even know what I'm doing anymore. I just screamed into my jacket and the camera was on.
Great
That's
job, because of the
fantastic. Bless you. What?
I did all the meetings. You missed
Whew.
one.
Okay. Wake up, Jimmy boy. Wake up, Jimmy boy. I need another notebook. 3 pages left.
So we're done.
Not even.
It's 5 over 6.
Not even.
It's 5, yeah, it is 5 over 6. Yeah, it's not 5 over 6. It's 5.
Oh no, my hand's really close to the camera and I don't like it. I'm just gonna put you over here. So you don't have to look at my hands.
4, 7, 10, 13.
I don't want to look at my
4,
hands.
7, 10, 13.
I don't want to look at your hands either.
So 3 12, so 1/4 each time.
My eyebrow.
Back up, you said 4, 7, 12.
4, 7, 10, 13.
Yeah, plus
I'm just gonna try not to draw any weird people in my
Plus
homework.
3 12.
Okay, yeah.
3 12 is 1/4. That means you're really good, but I'm still a little bit better. It'll change. It'll change. At some point, he'll end up being, most of you guys will end up being much better than I am. At some point. Just not yet. 63 is the one I've been waiting for.
Okay, that's it.
It's that copying thing. Copying of the problem that's, yeah. That's the toughest part. 63 is the world's largest champagne fountain.
Yum yum.
Well, that's what it
Champagne,
says.
cocaine, gasoline,
Reading what it
and
says
those
here.
things in.
What you singing, my dude?
Don't threaten me with a good time.
Okay, here we go again. From December 28th to 30th of 1999, Luc Bruce, director of Maison Luc Chalet Fontaine, constructed a 56-story champagne fountain at the Steigenberger Kurhaus Hotel, in
Netherlands.
Scheveningen, Netherlands. Yeah, that was bad. The fountain consisted of 30,856 champagne glasses. Assuming there was one glass at the top and the number of glasses in each row forms an arithmetic sequence, how many were in the bottom row or story? How many fewer glasses did each successive row or story have? Assume each story is one row. Okay. What I hope that we would do there is try something. Fair, isn't it? Fair. Okay. Try something. What do you know about this problem? We know that it's an arithmetic sequence. Okay? Which means that, yeah, so in our champagne fountain, how many are on the top?
One.
One. And then, we don't know, but we would be
Assuming 2.
adding something. We don't know what yet. And then we would be adding another something and adding another something, but the somethings are all the same. Okay. So it's an arithmetic sequence. Now that we know that, okay, we take out the thought of, champagne glasses and everything like that, and we just start trying to figure out what we need for an arithmetic sequence. What do they tell us? Do they tell us anything that's helpful here?
It's 56 stories.
So what does that mean in terms of arithmetic sequences? 56 terms, so
And it's 56.
It's 56.
There's 56 terms.
so what does that mean? What's 56 then?
The last number. The last
And.
term.
N.
Yes. And X.
N is 56. Do we agree with that? Me too. Is there anything else that they tell us? We know how many glasses there are total. Okay? So in terms of arithmetic sequences, etc., what is that? The sum. So S,
Is 3,000.
wait, S
56.
sub 56, right? The sum of the 56 terms, 56 rows, is
56.
30,856. Cool. Is there anything else they told us?
It increases, the A sub
There's
1.
1 on the top.
They gave us a sub 1?
Yes.
What's a sub 1? 1. Okay. All right, we can work with this. We got some info. They told us it was in 1999. That doesn't do us any good. 56 stories, got it. 30,856 glasses, 1 glass at the top. All right, what are we trying to find? Don't give me the words from the problem.
The 56 term.
The 56th term, also known as A sub 56. So this right here is asking us for A sub 56. Okay? Are they asking us for anything else? How many fewer glasses did each successive row have? So that is D. Okay. So we've turned this from a monstrous paragraph into an arithmetic sequence problem. So I don't even need that anymore. Let's go to work. How do we work?
A sub n.
Okay, so we know 2 formulas, correct?
Yeah.
One formula is A sub n equals
A sub
A sub
A sub
1
1 plus
plus
n
n
minus
minus
1
1
times
times
d.
d.
Can we use that formula right now?
Yes.
Yes.
Do we know this?
Yes.
No.
No.
Isn't that what we're looking for?
Yeah.
Do we know this?
No.
No. Do we know this?
Yes.
Yes. Do we know this?
Yeah.
Yes. Do we know this?
No.
No. So we got 2 unknowns. How do we feel about 2 unknowns?
Not so great.
Not so good. We want 1
One
unknown.
unknown.
So, do you think we're going to use this equation at some point in this problem?
Yes, later.
I do too, just not yet. So, we need another equation.
Shall we do this?
Sum. So, S sub n equals n over 2. I forgot. Oh, no.
1.
A sub 1 plus A sub n. How do we feel about this one? Do we know that?
Yeah.
Yes. Do we know that?
Yes.
Yes. Do we know that?
Yes.
Do we know that? Oh. So in this equation, how many unknowns do we still have?
1.
Is that good news or bad news?
Good news.
So let's go. Tell me what to write. 30,856
56 over 2
equals 56 over 2 times.
times 1 plus A sub 56.
Okay, I can do this. You can do this. 30,856 equals 28 times 1 plus A sub n. Okay, we have 2 options from here. Give me one.
Use the 28.
We can divide the 28. That's what I would do. The other option would be to distribute the 28. But if we distribute it, we're just going to have to divide 28 at some point anyway, so just divide the 28 now. So we divide the 28, which gives us 1102 equals 1 plus A sub. Oh, wow. A sub n. I wrote a sub n. I should not have been writing a sub n. What should I have been writing?
A sub 56.
A sub 56. That's one of my many faults. I do that all the time. You should be writing a sub 56 here. Is that reasonable?
Yes.
So a sub 56 equals 1101. What did we just find, by the way?
A sub 56.
I know that,
The
but
bottom row.
The bottom.
back in the context of the
How
problem,
many
we
glasses are in
found
the bottom row?
how many glasses are on the bottom level?
That's terrifyingly many.
Anyway, okay, what's next?
Now we plug it into the thing.
Can we now use this one?
Yeah.
Do we know this?
Yes.
Now we know this. Do we know this? Do we know this? Do we know this?
No.
So we're okay.
Yeah.
Cool. Go. Tell me what you write.
1,101.
1 plus 50, n is 56, so 55d. So 1100 equals 55d. D is 20, I believe. Yes. So what did we find out? Okay, what does D mean?
How many is being subtracted as you go down?
So how many glasses are on the top row?
One.
1. How many are on the next row?
21.
21. And the next row?
41.
41. 61. 81.
How would that look though? Because there's one.
Well, I don't think they're going to be like that. I think it's going to be, that would be my guess. Like maybe, I don't know, somehow 20 with the 1 there and then 40. But think about the planning that must have taken place here. How do you build that? Well,
How many
apparently,
How many glasses did they break?
I have a picture of this. I gotta show
I have
you.
the answer to that. How do you build that? Very carefully.
Ha ha
You
ha ha
think
ha.
they built it and they poured the champagne, I guess?
That would be my guess. That would be my guess, that they then poured it in and it overflowed and it did that whole, hence, champagne fountain. I wasn't thinking about that. Yeah, I didn't think about it either until. But what kind of planning does it take? It's not like you suddenly go, well, why don't I put 1,101 glasses on the bottom row? Ooh, here's another question.
Let's see if it is something.
Glasses need to be pretty sturdy, those ones at the bottom, don't they? I don't know. My name is not Luke Bruce, so I don't know exactly how they did it. You're probably right.
What did I do? I work in a
Probably a
winery and he
video.
does towers with wine glasses all the time.
There you go. You guys can attach the video of Luke Bruce doing that.
We'll put it on the channel. I'll look it up.
You sure you
I'm just.
want to look it up? Your phone
All right.
takes for.
Are we okay with
She's
that?
just being a little fussy.
But realize, by the way, like planning, math, physics, all the stuff that goes into doing something like this.
Why would you
I
want to
mean,
make
money.
Because it's fun.
What did they have to do? They had to buy over 30,000 champagne glasses.
That sounds like a complicated purchase to explain.
And what are the odds? What are the odds that there was some type of breakage? Wow. Wait, can I steal this for a second? That's what I'm trying to do.
Oh, okay. That's so pretty though.
Yeah.
Look at him, he's up there on the thingy. Oh, it's loading. It's spinning. There you go.
Oh, the last one.
Wow.
Loading.
It's like in a harness, but he's going really slowly.
Might just be my phone.
Oh my God, what if the harness broke right about now?
That would, you would be dead, honestly.
And drunk.
I'm drunk.
Happy birthday in October, yo.
Oh,
There goes.
oh, the person controlling the harness, that's so much pressure.
Yeah, accidentally.
That's why, Dang, I'd be shaking if I were him. I'd be
If he
like,
goes to port and then the glass tips over.
He's like swinging back and forth.
oh, it's the domino effect.
Forget it, yeah.
They're all gone.
We're starting all over again.
He's moving.
Oh, he just went for it.
Imagine dropping the bottle.
And being able to fly and hover yourself.
Yeah, that's tough.
I hate when I have to
Can
do
you
that.
imagine how long it took for the bottom to be filled?
Yeah, I mean, think about that. You've got almost 31,000 glasses of champagne.
I don't think our problem.
How are they gonna get more bottles?
It doesn't look like there's 20 at the top there.
Oh, one bottle should take care of it, right?
Yeah.
I think it's more like standard cups for like 1, 3, 7. I don't think.
I know it doesn't look like 21, does it?
I think our problem wasn't realistic.
You're right.
Yeah,
Anyway,
probably.
I have no idea how long this video lasts, so.
I think it's like 2 minutes.
It's like 3 minutes.
Oh, he's done.
Oh, done.
Is he gonna smash it? Please smash it.
On top of the tower.
Yeah.
There it is.
Great.
That's kind of cool.
Thank you.
I'm easily amused.
Me too.
All right.
What else can
We all
I
set?
do? I'm easily amused.
You have a song for literally everything anyone.
Pretty much.
Are there any other homework problems we needed to do? Good answer.
'Cause
Okay.
I don't know what happened here.
So, away we go.
You can have YouTube friends now.
Why do I need friends on YouTube?
It's literally, they're turning YouTube into Instagram.
Really? Have things gotten that bad?
Yes.
Okay.
Everybody's here now, right?
If I'm
81632. That's square. All of this is square.
if my parents now tell me because I'm doing Instagram that I'm not allowed to have YouTube, I'm probably gonna kill them.
What?
My parents tell me I'm not allowed to have YouTube now because it's like Instagram. I'm probably going to kill them. Someone.
Do you not have Instagram or Snapchat or anything? You're not allowed to have social media?
I have pictures.
You're not allowed to have social media?
No, I don't know.
All right.
Why not?
So,
It was just a weird parent thing. Because I didn't have social media until like halfway through my freshman year. And even then I didn't have a Snapchat until like sophomore year.
we're not adding the same thing every time. We are instead multiplying. When we multiply the same number every time, that is called a geometric sequence.
Okay, but whose last was that?
The word geometry.
Yes, this
Or
is
geometric.
totally, so we're going back into geometry. No, I'm just kidding.
We are?
Oh, God.
I would. I'm afraid.
Okay, all right, I gotta get rocking, so it's a geometric sequence. It's a geometric sequence because we multiply the same number every time. In this case, we're multiplying by 2. Okay, here's my next question. Is this a geometric sequence?
Yeah.
Are we multiplying the same thing every time?
No.
What are we multiplying?
1/3.
See, I thought we were dividing.
That's the same thing.
It's the same thing.
Dividing and multiplying are the same thing. So dividing is the same thing as multiplying by the reciprocal. I got it. I remember it now. Okay. Cool. So if we multiply by the same number every time to get from term to term, we have a geometric sequence. So since we have a geometric sequence, we need some formulas. So let's do some geometric sequence formulas. Here's our first one. A sub n equal, wait, what does A sub n mean?
The nth
The
term.
nth term. Whatever that means.
Oh my god, my head hurts.
Okay. So A sub 8 would be the 8th term. A sub 27 would be the 27th term. A sub 2.4 would be the
2.4th term,
Non-existent.
which does not exist.
A sub n, yes it was. A sub n equals A sub 1 times r to the n minus 1 power.
What's R?
Which begs the question,
What's R?
what the heck is r?
The rate.
This is. Wait, is this interest?
In arithmetic sequence,
No thanks.
we went up by the same amount every time, and we called that amount that we went up the common difference. So we called it d. But this isn't a difference here, is it? No, it's the number that we multiply
What is
by
that
every
now?
time, which we're going to call
Oh, that's depressing.
common ratio. Common ratio holds the same
It's gonna be hard to explain to my parents.
Common ratio is what we multiply each time to get to the next term. So,
I just
in our
wrote
first
common
example,
ration.
the common ratio would be 2. In our second example, the common ratio would be
It's 12.38.
That's cool. Okay. So we have the formula for a sub n. What formula should we come up with next? S sub n? What does S stand for? Sum.
Oh, you did this.
I hate this formula. This is like my least favorite formula in almost all of math. A sub 1 times 1 minus r to the n over 1 minus r.
I'm good.
Not
Can I
gonna
show
write it
it?
down yet.
Can I show that to my mom?
I don't know, I just don't like it. It's weird, it's kind of a pain, there's nothing.
Can I get rid of my pentagram?
No,
So a sub 1 multiplies
I
that
do
entire
too.
fraction.
What happens when I show my mom?
If you wanted to, if you
Don't
felt
try and
strongly
pay.
about it, you wanted
Black
to do
pencil.
that, that would be okay too. That's wrong. And for the most part,
off for a couple days.
that's all we need to do in 12.3a.
Says who?
Because the types of, okay, I really gotta be able to talk without you guys having this, without there being this undercurrent of talking all of the time. I'm about to talk about a couple of other things. I'm not saying stay. What I'm saying is we're actually gonna finish 12.3. Because since I'm not gonna be here on Thursday, I can kind of do a double whammy today. Tomorrow we'll do 12.5a, and then Thursday will be a work day. Okay? Good luck.
Where are they going?
Something for band.
Oh, yeah.
So the types of problems that you have on the 12.3a homework are things like,
Wait.
there we go. Is the sequence geometric? If it is, find R. Same type of problems that you had yesterday. Remember the first set yesterday said, is the sequence arithmetic? If so, find D.
Yep.
Same thing here. The second set says, here's a sub 1 and here's R. Find the first 5 terms. Then the next set says, write the formula for the nth term if we give you a sub 1 and R. Okay. The nice thing, the only good thing about this is that there's little to no simplification to do on these. Like you plug in a sub 1, you plug in R, and that's it. I mean, you can't multiply a sub 1 times R or anything like that. You just, and then it says, here are the first 4 terms. Find the 12th term, things like that. So you would just plug it into the formula, plug in 12 for n, and finish it up. And that's all of the 12.1a stuff. 12.3a, that's what I said. 12.3a. Me too.
You said you don't multiply a sub 1 times r?
Well, you can't. Think about this. What is 2 times 4 to the n?
Oh, 2 times 4 to the
Is
n.
that 8 to the n?
No,
Why not?
because the 4 has the exponent.
Because what has the exponent?
The 4.
Just the 4. So this is saying 2 times 4 times 4 times 4 times, and we don't know how many 4s there are. We can't change this to 8 times 8 times 8 times, you know what I'm saying? So that's why we can't even simplify it. It's just, that would be it. Does that make sense? So a sub 1, R, There would be that n minus 1 up there, and that would be it. That's all we could do. So the nice thing about the a sub n formula is that plug in your a sub 1, plug in your r, done. Okay? So give me the phrase of what I just wrote. Series? Okay, I heard series, so that's good. That's one of the 3 words in the phrase.
Geometric.
Geometric. So it's a geometric series. Okay, so that's 2 words. We got one more word. Well, series implies sum, so we don't have to say that again.
Arithmetic? I'm confused.
What else is a part of this that you see that causes problems?
It goes to
That is absolutely correct. It is infinite because it goes on forever. And it is geometric, and it is a series. So therefore it is an infinite geometric series. The phrase makes sense, right? Okay. So here's the interesting thing. I think it's interesting. We are going to find the sum of the infinite geometric series. How is that possible? That's a great question. There's a formula?
Sigma notation?
I hope there's a formula, actually, because otherwise we'd be adding
Would we use part of
a
sigma?
lot of numbers.
a lot of numbers. Kind of an infinite number of numbers, and that might be problematic.
Wait, how is there an answer?
Good question. We'll figure it out, hopefully.
That's crazy.
There is a formula. So, what's the beginning of our formula going to look like?
Infinity.
S, which stands for sum. But here we had S sub n.
That's it.
Yeah, and we don't tend to write the infinity, so we're just going to write the S. So the difference is if it's S sub something, then it's going to be the sum of the first however many terms. Could be S sub 12, it could be S sub 7, it could be S sub 52. That implies that we're going to add that many terms. If it is just S, then that means that we're going to be finding the sum of the infinite geometric series. What do you think that formula looks like? It's a big deal, huh? Okay, ready? Grab whatever extra ink you need for your pens or pencils, lead for your pencils.
I don't have a
So
lot
here
of
we go, we're gonna
room.
get started. There it is, we're done.
Wow.
I know, it's kind of wild.
So
A sub
long.
1 over 1 minus r, and that is it. I like that formula. I don't like that formula. That's
Why is that one so much more complicated? There's less numbers.
well, part of it's that
I can't. I don't.
what do we not have to put into this one? N. Why do we not have to put n in? Because that's infinity, basically. So it's kind of a, in some ways, now I guess we can think about it. I've never really thought about it, but I guess, if you compare this one to this one, basically we're losing the 1 minus r to the n. And that's because when n becomes infinity, well, we'll actually talk about that more in a second. Ooh, this is good. I like that. We'll talk this through. I want to talk about that. But anyway, what I would like you to do right now is use that formula to find the sum of this infinite geometric series.
There's this now. Because Blackville breads.
Yes.
A necessary part of every hand. Damn it. It didn't show up. Oh, crap. I'm going to get it on my neck.
9 would be 9
fired up. She just says 2/3. Don't miss it.
I'm dying.
She likes school. She likes being there with her friends. She likes learning stuff. She likes school. And she never wants to stay.
What's R?
It's the difference between the. Would R be -3?
She, I got her jerseys yesterday. What number is she?
0?
Number 0. She wanted it. In fact, she's dealing with, I don't know.
Why is it good?
She's dealing with the fact that it is an adult large. Just because she wanted number 0 in this case. So she's all excited. They have a game tomorrow too. I'm hoping that tomorrow at this time she is as excited as she is right now. Because today could be ugly. We got an answer? No.
Well, I have
27.
Well, I just said, do we have an answer? I didn't say, are we convinced that it's the correct answer? I just said, do we have an answer?
Yes.
Or
Okay.
13.5.
What's ace of
Is that what
1?
you got?
9. Over 1 minus, what's R?
1/3.
1/3. Equals 9 over, what's 1 minus 1/3? 2/3, right? If you have a pie and you lose 1/3 of the pie, you have 2/3 left. Now, here's one of the places that people got messed up earlier today. They looked at this and started to try to do all kinds of weird, funky things with it, okay? A reminder, this is back in 5th and 6th grade stuff, okay? So just do it correctly, though. This one you can't shortcut.
Yeah.
9 divided by 2/3 is the same thing as 9 times 3 halves. Dividing by a fraction is the same thing as multiplying by its reciprocal. That seems to be coming up. We've said it a couple times today already, right? So just keep driving that into your head. Dividing by a fraction is the same thing as multiplying by its reciprocal, which gives us
27 over 2.
27 over 2. There it is.
Or 13.5.
There's our answer. Matt, you said 27 over 2 is
13.5.
13.5. Okay, so either answer there would be totally fine. That's weird, isn't it? Why is it weird? Yeah, what would you expect here? You'd expect probably a bigger number, probably something repeating or something like that. Yeah. So putting it in perspective is kind of hard. And I agree with you here. Okay? So here's the best way that